Hello students, in the previous class we have seen the laws of photochemistry. Today let us discuss about quantum. Generally we have seen the definition. So what is the definition of quantum? The ratio of the number of molecules that react to the number of quanta of radiation absorbed, or we can say number of moles that react to the number of Einstein of radiation absorbed, we can say. So now let us see about experimental determination of quantum. So generally here we are having this experimental arrangement of quantum. So we are taking light source, lens, monochromator, reacting cell, thermophile and thermostat. So let us see one by one. So for what we are using this apparatus? So this apparatus is used to determine the quantum yield mainly, we can say. So when you take light source, so light source is nothing but what here? It will give radiations of intensity in the spectral range. Means a common sort of light here we using is which will give spectral range mainly. Okay, spectral means what? Light. So means what here? It emits the radiation of spectral light, we can say, which will give intensity. Means it is the common source of light. Mercury with vapor lamp we are using, or we can use iron and carbon arcs in some cases also. Okay, some cases metal lamps filaments also we can use. So what is the use of light source, we can say here, which will emit radiation of suitable intensity in the desired range. Okay, so then what is the use of lens? Lens is nothing but it will give some focal length. Okay, so monochromator, it will cut all the radiations of desired wavelength. Okay, or whatever radiations it is getting, it will cut and it will give perfect radiation. That one we call it as monochromator, single chromator. So next one, what is the reacting cell here? Reacting cell is nothing but it is made up of a glass or quartz. So it is used when the wavelength light used in the visible region. Okay, so when the light radiation is getting here, so what will happen? Visible range we are getting. For light radiations, it will have wavelength between 350 nanometer. Only quartz cell is used here. So how much we are using? The wavelength 350 nanometer. Okay, so then what is detector? It is usually a thermophile or a actinometer which will measure the intensity of light radiation. Whatever rays it is getting, it is going to measure. Okay, so this is about diagram. So then thermophile. So generally this thermophile consists of number of thermocouples. For example, so this is a thermophile. Okay, so this is one of the thermophile. So when you take this thermophile, which will be kept in a box, so these two wires are connected to a some milli ammeter. Okay, so now let us see about this thermophile. So generally this is consisting of a number of thermocouples joined in a series, we can say, which will be joined in a series. Okay, so a thermocouple consists of, this thermocouple consists of two rods. One is, this one is we call it as silver, this one we call it as bismuth. Okay, joined together. So one set, this set, what will happen? This set is, whatever it is blackened, it will absorb all radiations. And coming to this one, the other set, what will happen means it will protect from the radiation at constant temperature. Clear? So what will happen? So here the thermocouple, series of thermocouple is there. It consists of two rods, that is silver and bismuth. This will accept all the radiations, it will protect from the radiation. Okay, so the what happens here, it will maintain at constant temperature. So by it is placing in a box. So this thermopile is placed in a box here. So whenever the radiations falling So the radiation is falling, it is blackened. Okay, so blackened metal strip are almost completely absorbed by it. Here the heat radiation, whatever we are taking. So what is the heat radiation here? The heat radiation is going to absorb the radiation. Heat radiations with light radiation means which is associated with the light radiations. It will absorbed by a black, this one. Okay, so whenever the heat radiations is getting, that also it is going to absorb by this silver one only. Means then when we raise the temperature, automatically to the set of junction, and this one is the hot end, this is the cold end. So means what happens, the difference between this temperature we have to found. So the difference will produce a electric current. Then this thermoelectric current in the circuit can be measured by a milliammeter to the thermophile. So the intensity of light radiation observed can be measured through what here? Can be measured through calibrating the thermophile when radiations of known intensity. So from this intensity of light absorbed, then energy of incident radiations can easily be calculated. So this is nothing but what here? So this is nothing but experimental determination of quantum yield. Okay, so means what the measurements were made before and after passing the light through the cell only. So the two measurements give the energy of radiation. So this is nothing but this one. So experimental determination. So let us see about generally quantum yield consists of two processes. So according to Stark-Einstein difference, what I have told you, only quanta of radiation is observed from each molecule. That one we call it as, according to law of Einstein's, what we have told, every reacting molecule will observe one quanta of radiation. But coming to here, number of reacting molecules should be equal to number of quanta observed. Clear? So according to Einstein law, what we can say? According to Einstein law, we can say that every reacting molecule absorbs one quanta of radiation, we can say. Means what here? The number of radiation should be equals to number of reacting molecules. But it is not true. For example, if you take a small molecule of if suppose a small amount of light absorbed, it will bring big change in a reaction, bring a large change. If you take a large amount of light absorbed, bring a small reaction. Okay, so this is nothing but what here? So this is nothing but quantum yield